Hello everyone, welcome back. So today we are going to go ahead and start on the next lesson. Again, I'm going to go ahead and be using the joinpd.com. It seems to be the most interactive program or website that I've used so far, and it's easily accessible to anyone who has internet. It can be on your phone or your laptop. So while it says that it's waiting because there's no students currently logged in, so I'm going to go ahead and join um, as if I was being the student, obviously, so you can see how I would be using this. And so it's going to ask you, let's see, how you're feeling. Let's see, before we even join, make sure that you are out from the other one that we just did, and then you go back and do joinpd.com. You enter the code, so NFYNX. Okay, I'm feeling pretty good. And then it's going to ask, I'm going to go ahead and start the class. It's going to ask, how was the homework assignment? So I'll just go ahead and put here, just so you guys can see what's something that they can be doing. If they had a really hard time, then obviously it would be around here. If it was somewhere in the middle, then around there. Okay. So now, last time we were doing the learning the volumes of prisms. Today it's volumes of pyramids. So our goal will be to find the volumes of pyramids and then use volumes of pyramids to solve real life applications or real life problems. So the very first one is that you should see on your screen would be finding volumes of pyramids. So here's just something before we even begin. So consider a triangular prism, which we learned last time. Again, the ones that have the bases as triangles and then the sides are rectangles. So consider a rectangular prism or a triangular prism with parallel congruent bases, triangle JKL and triangle MNP. You can divide this triangular prism into three triangular pyramids. So these are the three. We have the prism here, and then these are the three different pyramids that are created. So the volume of a pyramid, we have it as follows. It's a third times the base times the height, where B is the area of the base, so it's this portion here, and then H is the height. So we should be familiar, obviously, with the B and the H. The only difference here is that now we're dividing it by 3. Okay, so the very first example, we have find the volume of a pyramid. So its volume equals a third base times height. Now, in order to find the base is a triangle here, so it's a half times 4 times 6, which is equal to 12, and then the height is given to us as 9. So all we do is multiply these two and then divide by 3. So we end up getting, so we have a third times 12 times 9 is equal to a third times 108, which is equal to 36 cubic centimeters. I'm sorry, actually, in this case, it's not cubic centimeters, it's just cubic meters. So I'm kind of actually glad that I made this mistake, just so that it shows you how quick and easy it is to oversee the different units. So when you are working on these on your own, do make sure that you are paying attention to these, as it's something that can be very easily overlooked. But if you were to do this on a quiz or test or homework, it's obviously going to be marked wrong or partially wrong because it's not in the correct units. So again, because it is volume, it's cubic, and then if you are working with, obviously this is meters, then it would just be cubic meters. Okay. So far we haven't really covered too much, but I do want to see how you're feeling with all of this stuff. So drag your dot to how you're feeling, and then I'm just going to go ahead and show you the response that I would see. So either yes, I'm doing well, I'm a little confused, or stop, I need help. Obviously, I think you're going to be getting a little bit. You should only have a couple here. I mean, I realistically would not want to, but we have to be, you know, understanding that there are going to be some students that are going to be really struggling with this. So just keep this in mind. If you have a lot that say stop, I need help, then something is wrong. And so it just lets you know that there was something that wasn't as clear as maybe I would have intended it to be. And then obviously we want a little here, and then mostly we should get keep going. I understand, and that's just a quick, informal assessment just to see, or a self reflection, pretty much just that lets you know how well the lesson is going. So now here's the opportunity for you guys to go ahead and try this on your own. So it says find the volume of the pyramid. So I'm going to go ahead and try it on my phone just so that you guys can see as I'm working with it. So I'm going to show the response. And let's see. So, okay. Let's see. So I'm going to go ahead and try this one just so that you can see, again, what it is that I would be seeing at this moment if I had obviously all my students online. Okay, so obviously it's a little bit, one of the things is it doesn't really give you too much room to do it with if you're using your finger to write the responses. So which is the reason that you might be seeing some of this kind of just overlapping the entire problem, which is fine. So it's going to be a third times my formula is base times height, a third times the base of this pyramid. Well, in this case it's a square because if you noticed, all the sides are congruent. um, and so we have, and then it tells us that it's a right angle here. So 10 times 10 is 100. Multiply that by the height, and then so that would be 120 divided by 3. So let's see. I'm going to go ahead and just erase this portion here so I have enough room. So it's 120 over 3, which would be equal to 40. Okay, so let's actually move on to the solution portion. Obviously, when you have enough of this, and you can kind of assess your students and see how well they're understanding it, then we move on and we go over to the next slide. So here we have the solution. We have a third base times height. Well, the base is 10 times 10, which is equal to 100. The height is 12, and then all I have to do is just multiply these two numbers and then divide by 3. Now this portion here, again, what I did is I multiplied these two numbers and then divided by 3. But obviously you're going to have students who they're able to quickly simplify the 12 divided by 3, and so they'll just go ahead and cross this out, and there'll be 4 times 1200. Let's see, what did I get back here? Oh, you know what? I think in the other one, when I was doing it, I actually missed one of the zeros. So it's actually, this is the correct one. So it's actually 1200 divided by 3. So I would have gotten 1200. This, yeah, 1200 divided by 3, which is 400. Yeah, it would have been 400, not 120 cubic centimeters. So see, even here, obviously, these are little mistakes that I'm making, but it's also another way to use it to your advantage or to my advantage, and just make sure that the students are catching these mistakes, and them, they're not just sitting there and taking everything in, but they're actually trying it themselves. And obviously, if I have something different from what they got in the solutions, then one of us got it wrong. And obviously, if there's enough of them, um, then usually even my top students, and it'll force me to make sure that I really did what I was supposed to do. In this case, I overlooked a zero, and it was 1200 divided by 3, which would have been 400. Okay, so then our answer would have been 400 cubic centimeters. Okay, so now we're going to go ahead and try this one. Now, this one's a little bit more of a challenge because obviously we do have an area, because we know that all of this is a regular polygon here. Then I can use the 1/2 a times p, but I'm still going to have to find the apothem of one of the triangles here. I'm going to have to create, so I have 1, 2, 3, 4, 5, 6. I have 6 sides, so it's a regular hexagon. And I know that I'm going to have to be using with trig functions or trig ratios to find the apothem of this portion, and then I'm going to go ahead and use that to find the area of the entire thing. So I'm going to go ahead and just move on to the solution portion here. So my volume is a third base times height. Same thing, it's a pyramid. Now the base, again, I'm going to be using the trig ratios to solve for the height of the triangle. And I need to know my central angle first. So I have 360 degrees divided by 6 sides equals 60 degrees. So this is the central angle here would be 60. Now I'm only trying to focus on a half of the triangle. So I'm going to be dividing that by 2, which is equal to 30. So this angle here is equal to 30. And then I know that this here, the entire side of this triangle, is 12. So when I divide that by 2 to also just focus on this portion of the triangle, then it's going to be 6. And so I'm going to go ahead and move on because this is a few more steps. So far, this is what I have. My unknown, or my apothemus, x. And so I'm going to be using tangent because it's opposite over adjacent. So my goal here is to find x. And I'm using the opposite side, the adjacent, so that's tangent. So tangent of 30 equals 6 over x. All of this, at this point, you should be familiar with how to solve it. So that means we would simply, either cross multiply or multiply by x, however it is that you want to do it, or that's easier for you. But we wouldn't focus too much on this part. At least that's not the goal now. So now we're going to go ahead and solve for x. Make sure one thing that I do want to emphasize is that when you're in your calculator, you want to make sure that you are in degrees and not radians, because that will give you a completely different answer. So just keep that in mind. And so for x, we have 10.39. And so the area of one triangle is a half, the base is 12, and then the height is 10.39. And so that's 62.34. Now that was the area for one triangle, but if you remember, I'm going to go back, there were 6 sides, so technically 6 individual triangles that you could have broken this into. So I'm going to go ahead and multiply this area by 6. And so the entire base now is 374.04. So now the volume is a third, again, base, which is this, times the height. We go back to the original problem. The height is given to us by 20. So we're going to go ahead and multiply that, and then I get 2493.6 cubic centimeters. Now let's make sure that my units are correct. Okay, in this case they are. So just again, make sure that you are being very careful with the units, and then just not overlooking at that small thing. Okay. So now we're going to go ahead and go on to a few real life applications or problems. It's just a really nice thing to do also, just so that you're allowing your students to make those connections and to see how the formula that they're using in class pertains to real life applications. You'll get a lot of students that are obviously questioning when I'm going to be using this, or pretty much, why should I care? I'm never going to have to see this again. But there are instances, obviously, where you are going to be using it. It's just not a daily thing. So here we have a pyramid in Egypt. Originally, Khafre's pyramid, I'm not sure how to pronounce that one, had a height of about 144 meters and a volume of about 12,218,800 cubic meters. Find the side length of the square base. So here we have the solution in step by step. So the first thing is obviously knowing what formula you're going to be using. Since it's a pyramid, it's a third base times height. And now we're going to go ahead and just substitute in all the values that we know for that. So they gave us the height, they gave us the volume, and so we're just going to go ahead and plug that back in there. And then all we're left to find really is just the base. So now we're going to go ahead and multiply each side by 3 to get rid of that here. And then we're going to go ahead and divide both sides by 144. And then we're going to go ahead and take the square root of that, and we have x is about 215. And so obviously they forgot the units. So since we're talking about meters, then you would make sure that you're talking about meters as well. Okay, so here's another one. Just dragging your dot to how you're feeling. I want to know if everything is making sense. So I would ideally give you guys a few seconds to go ahead and do this. And then obviously I can show my responses and see how well everyone's doing. Okay, and then we have a couple more. We're almost done. So now we're using the volume of a pyramid again. Find the height of the triangular pyramid. So here the area of a base it's a triangle, so it's a half times 3 times 4, which is 6. And then everything else, they give us a volume, so we're going to go ahead and just plug that in there, and then we're solving for h. So however you want to do this, in this case, I just went ahead and I divided 6 by 3. And so that's 2h equals 14. Divide both sides by 2, and I get h equals 7, or 7 feet. And then our final exit ticket question is, explain the difference between a triangular prism and a triangular pyramid. Okay, and then just obviously this is a little bit, we learned the triangular prism in the previous section, and then this one was the triangular pyramid that we just learned today, so we would go ahead and go over it for the next lesson. Alright guys, so that was pretty much it for today's lesson. I hope you enjoyed it, and then I will talk to you guys next time. Bye.